Hello everyone. Let's learn about this list of Python. So in all the programming languages, we get this data structure. And inside the Python data structure, we have this inbuilt data structure, which is called list. So what is this data structure? This data structure actually provides you a way to handle your data effectively or efficiently. And this list comes inside the data structure. It means list is also used to handle your data efficiently. Just to understand this list, let's take very simple example of your Python program. Here we have this very simple iteration of a Python program where we have this data input, which is 1 comma 2 comma 3. We have one Python program to check if numbers are integers or not, and based on the validation it is going to provide us the output as true or false. So here we have only three numbers, this 1 comma 2 comma 3. We can provide the number one by one and it will validate whether that number is integer or not, and based on that it will provide us the output. But in real case, in practical case, you might have hundreds of number or thousands of numbers. Then in that case, are you willing to provide each number one by one to your Python program just to validate whether it's integer or not? I guess no. Because if you are going to provide everything one by one, then you can do that manually too. But we are using this programming to simplify our task. So in Python, for this, we have this list. In place of providing all the data one by one, we bundle that data in data structure called list and provide it to the Python program to process it. So earlier we were providing this data one by one to our Python program. But now what we did is we bundled the complete set of inputs into one entity, which is list, and we have provided that list to our Python program to process it. So our Python program will process the complete list, and based on the verification, it will provide us the output whether all the data is integer or not. So yes, it simplified our task. So this is the list. And how to declare a list? First, let's see the representation. Inside the representation, we are going to represent our list between the square brackets. So in this example, we have this 1 comma 2 comma 3, this apple, this empty string, then 100.10 and none. So from here we can understand that we can store any type of data in a single list. It is independent from the restrictions. What restrictions? Like that our list need to be of a single data type? No, it do not have any kind of restrictions like that. Our list can attach, or our list can store multiple kind of data at once. So in this way, we can create a logic into our Python program. Okay, if the data is type of this, then do this. If data is type of integer, then do this. If data is type of string, then do this. So again, by using a single input in our Python program, we are able to handle multiple kind of data, or we are able to process multiple kind of data just by providing single input. And how to declare it in your Python program? Like this. You can provide either only square bracket, or you can provide the list function to your variable. Once you do this, that particular variable will become the type of list. So this is the way we understood that how to declare the list. And again, there is no need to define the size of list. It's all dynamic, like like Java or C, where we have to define the size. Inside the Python, we don't have to define any size. It's all dynamic. If you are going to add more and more data to your list, then Python will automatically allocate more and more space and addresses to your list to store your data. So it's all dynamic. You don't have to worry about assigning the size. Your list can be of one length, two length, or 1000 length. It's all about your system specification. So now let's learn about the indexing in list. So here we have our list. It have three elements. this 1, comma 2, comma 3, or you can say we have three items, this 1, comma 2, comma 3. So there are two type of indexing. One, positive index, which executes from left to right. Once when we are learning about the positive index, what happens is for this indexing is kind of basically providing the address to your elements of list. So with this example, we can understand that, okay, this 0 address is for the element which have the value 1. Again, this index 1 is representing the value of an item which is 2. This index 2 is representing the value of item which is 3. So, so it is the positive index and it is the negative index. This starts from right to left and it starts from -1. This -1, -2, -3. Why we need this positive index and negative index? So when it comes to the list, it might be possible that you need an item which is closer to the starting point, or you need an item which is closer to the end point. So if you know that your element is going to be nearer to the starting point, then you will use the positive index to retrieve that data. Or if you are going to retrieve the data which is closer to the last element of your list, then you will use the negative indexing. Why we need this positive and negative index? Because when we provide this index number or address of that particular element, your Python interpreter will start the iteration from that direction. So to reduce the time of that iteration to reach to that point where you want to retrieve the data, we are using this positive and negative indexing. We will discuss about this iteration more in our upcoming lecture when we are actually dive into our data structure design. So it is the first part. We are going to learn more about our data structure in Python in later series. So if I want to access that particular element or retrieve that data from that list, what I do is I provide the index number with this kind of representation, as you can see on the screen. So if I provide the positive index, then I have to use this 0, 1, 2. It will provide me the sequentially from left to right. And if I'm using this negative index from right to left, then again -1, -2, -3 will return me the output of 3 to 1. Okay, so it's clear what is the indexing in list. So when it comes to list, we understood what is list, but this list have to do some action through the Python, and the Python, as it is a inbuilt feature of Python, so this Python provide you a way to add or remove data from your list. So first comes to the add. It provide you three main operation: append, extend, and insert. What is this append? You have your list, and if you are using this append, it will add that particular data at the end of your list. At It will add that data after the last element of your list. This appends will take then it this append will take the data inside their bracket and it will add that data to your list at the end. Extend. Extend, when you have two lists, then what you have to do is, like, you have two lists and you want to merge those lists, then we use there is extend. Coming to the insert, if you know at which index number you want to add your data, then at that position we use the insert. And like the add, also there are methods to remove for there are methods for remove too. That is pop, remove, and clear. What the pop will do is it removes and return the element at the specific position. If we have provided the index, it will pop out that index positioned element and it will return it to the program. Or if you haven't provided anything, at the place of index, then it will pop out the last element, this remove item. Uh, let's say you have this list 1 comma 2 comma 3, and you have used this remove, and inside that bracket you have entered 2. So it will remove that 2 from the list, and the remaining list you will have this 1 comma 3. Coming to the clear, this clear will remove all the item from the list, and it will make your list empty. These methods we will do the practical too. So let's jump into our practical. So here we have our Python terminal, and what we are going to do is we are going to create one list, this 1 comma 2 comma 3 comma 4 comma 5, and we are going to add one more element too, just to show what will happen when we are going to use these methods. So here if we do this a dot append, and what I do is I will append 6. So if I provide the output, it will give me 1 2 3 4 5 2 6. So it added the element at the last of the list. Okay, so now here we have this a, and we are going to create one more list, which will be 6 comma 7 comma 8 8 comma 9. And what I'll going to do is a dot extend with b. So now what a will be, now what a will have is 1 2 3 4 5 2 6 6 7 8 9. It concatenated the two lists which we have into one list. So it is the second operation. So we have this append, extend, and one more operation what we had is insert. Okay, so what we do is a dot insert, and inside the insert what I'll do is at the first position, at the first index, I'm going to add this 99. So let's see what will happen to our list A. Okay, so this will be our 0th index, this will be our index number 1. So at the index number 1, it inserted the element. So the 3 operation to add an element to your list is completed. Now let's check for the remove part. So here we have this A, and we are going to use our very first pop. So a dot pop. First, we will not provide any index, just to see what it will return. From our discussion, it should return 9. Yes, it returned 9, and now this A list will not have 9 into its list. Okay, yes. So it is still the 8. It removed the 9. Okay, so let's a dot pop, and what we are going to do is we will remove the last second element. So it should be 7 from the current list. Okay, yes, it pop out the 7 number from our list from the last second index, from the -2. So after the pop operation, this 7 should not be there. So again, we are going to check what will be the data inside the A. So this A will have this 199, 2, 3, 4, 5, 2, 6, 6, 8. This 7 is removed. Now it's time for the remove. So this A dot remove, and why I use this double 6 or this 2 at 2 times just for this remove part, because if I enter 2, so wherever it finds the 2 at the first time, it will do the operation, it will come out. It will not go and search for the same number second time. So if I do this a dot remove 2, so it should remove the 2 from the second index. It's 0 1 2, and inside that list this 2 should be there. So again we are going to check, and yes, this 2 is there, but this 2 the 2 before 3 is removed. So our explanation was correct. Now it's the time for the clear. So what we will do is a dot clear, and it should empty the list. And here we have A, and now it is completely blank. So that's it for the part of this list, and I hope you liked it, and I was able to uh, teach teach you about the list. If there is any doubt, please let me know in the comments. Uh, I will definitely tell you the solution, or I will try to resolve your issue. And please let me know if you like the video. And because of your feedback only, I'm going to improve the video quality and explanation. So that's it. Thank you.